So we're looking at writing equations based on story problems again. Now we said yesterday the key to any story problem is to read that story problem at least 3 times. Sometimes we're going to have to read more than 3 times, but we're going to have to read at least 3 times in order to write these story problems. The first time, the only thing that we care about is defining the variable. Now we're not trying to say what x is equal to at this point. We're trying to say what x represents in the story. And it's easy hint, guys. It's always going to be whatever they're asking you to find. Okay, they want to know how many hours this person's going to have to work. Well, then h equals hours working. They want to know how much money this person's going to have at the end of summer. X equals money at the end. Okay, that's what we need to look for when the first time we read through. And it's the only thing we care about the first time we read through. The most important piece. Everything else is based on it. The second time we read through, that's when we list the important numbers in those operator words. Okay? I know this is math class and we want to run to those numbers, but we're going to wait until the second time we read through to consider those numbers. So we're going to list the numbers and the important words to go along with them. Okay, then we read it a third time, and that's when we build the equation. We ask ourselves what operations are being done and in what order. Okay? Now, when we're building the equation, we're not trying to go in reverse order. We're not trying to undo things. We're trying to write exactly what's happening. Okay? So let's look at number 1. Let's read through. And the first time, the only thing that we care about is defining that variable. Okay, so there we go. First time we read through, all I want is a variable. So Lisa is saving up money to buy a new phone that costs $250. She already has $45 saved, and she earns $55 each week for babysitting her neighbor's kids after school. Bless you. Write and solve an algebraic equation that can be used to find how many weeks she will have to babysit in order to have enough money to buy the phone. So what we're looking for is how many weeks she'll have to babysit. So that's our variable. That's our unknown quantity. So we'll say weeks babysitting. Okay, that's our unknown. And we get to pick whatever variable we want. So since we're talking about weeks, let's say W is weeks babysitting. Okay, and the first time we read through, that's the only thing we care about. It's the first thing that we're going to write down. Everything else in this story comes back to how we define that variable. Okay, so then we read it the second time, and that's when we look for the numbers and the operator words. Okay, so Lisa's saving up to buy a new phone that costs $250. Okay, she already has $45 saved up. Okay, so that seems important, $45. And she saves $55 each week for babysitting her neighbor's kids after school. Okay, so $55 each week for babysitting her neighbor's kids after school. Write and solve an algebraic equation that can be used to find how many weeks she'll have to babysit in order to have enough money to buy the phone. Bless you. Now, we need to say what each of these numbers are. Having the number themselves is not enough. We also need words that go along with it. So this $250, that's the total cost of the phone. Okay, that's how much money she needs to have. She needs to have all of it. The $45 is what she already has. So we can say $45 is what she already has. And then lastly, she earns these $55 each week. So $55 is what she earns each week. Okay, and we're actually writing this stuff down. We're not just thinking it, we're actually writing this stuff down on every single one of these problems. We need to be thinking about it, and the only way I can know that you're thinking it is if you're writing it down. Okay, then we read it a third time, And that's when we can build our algebraic equation. Okay? So, Lisa's saving up money to buy a new phone that costs $250. She already has $45 saved, and she earns $55 each week for babysitting her neighbor's kids after school. Write and solve an algebraic equation that can be used to find how many weeks she'll have to babysit in order to have enough money to buy the phone. Now, it says write an algebraic equation. That means we have to write an equation with a variable. We cannot just use the arithmetic approach. We actually have to write an algebraic equation. So, let's talk about what's happening here. She already has that $45. So it sounds like I'm going to have that $45 to start with, and then I'm going to add to it. Well, what I'm going to add is the money that she earns each week. She earns $55 each week. Now the question is that word each. Each can mean multiply, or it can mean divide. We need to think which one it means here. Divide is when we're splitting something up. Multiply is if we're doing something again and again. Well, are we repeating that $55, or are we splitting that $55 up? What do you think, Dalton? We're repeating it. Okay? We're multiplying those $55 times the number of weeks she's babysitting. Okay, what about that $250, that total amount? Very good. Okay, we need to add all this money together that she gets, and it needs to equal that $250. She wants to have enough to buy the phone. So we can build the equation. We can say she starts with those $45, that's what she already has, and we're going to add $55 to it each week, which means times the weeks that she's babysitting. Now this is how much money she has. We need that to equal $250. We need that to equal the total price of the phone. Now guys, I'm confident after the last couple of weeks we can solve that equation. Okay, I have no doubt about that. What I want to focus on right now is building these equations. Okay, so we'll come back to it to solve it in a little bit. Right now I want to go on to number 2. Okay, and I want to look at number 2 and write an equation for number 2. All right, so let's get Alec. Read number 2 for us, please.
Art is riding his skateboard home from Springfield Elementary School, a distance of 26 blocks. He has already ridden 12 blocks and continues to cover 3 blocks per minute. How many more minutes will Bart be on his skateboard before he is home?
All right, so what are we looking for here? What's our unknown in this story? What are they asking us to find? Okay, how many more minutes? That's what we're trying to find. So that's our unknown. That's going to be our variable. Minutes on skateboard. And they don't tell us what variable we have to use. We get to pick whatever variable we want. So, minutes on skateboard, let's use M. We could be boring and just use X or Y. But let's use something appropriate. Let's use M for minutes on that skateboard. Okay, then we're going to read it a second time. And the second time we read through, that's when we look for those numbers and those operator words. Okay, so read it a second time for us, please.
Bart is riding his skateboard home from Springfield Elementary School, a distance of 26 blocks. He has already ridden 12 blocks and continues to cover 3 blocks per minute. How many more minutes will Bart be on his skateboard before he's home?
All right, so what are some important numbers that we see in there? 26. And what's 26? Okay, that's the total blocks, his total distance. So we'll say 26 blocks is his total distance. Okay, what else do we see? 12. And what's the 12? Good. 12 blocks is what he's already ridden. Okay? Anything else? 15, where's 15? 3, okay? Where's 3? Good. 3 blocks is how many he covers per minute? Okay? We can choose any letter that we want. For this one, let's choose M. Okay? On the other ones, you can pick whatever variable you want, but on this one, let's pick M. Okay? All right, now we have the numbers. We have the variable. Let's read it one more time. Let's get a third read here so that we can help work on building this equation.
Bart is riding his skateboard home from Springfield Elementary School, a distance of 26 blocks. He has already ridden 12 blocks and continues to cover 3 blocks per minute. How many more minutes will Bart be on his skateboard before he is home?
Okay, so this 12 blocks, this is what he's already ridden. So we're going to start with those 12 blocks, and we're going to add to it. Okay, now what are we going to add to those 12 blocks? What are we going to add to those 12 blocks? The blocks per minute, okay? We're going to add 3 blocks per minute. Now that word per, there it is again. It can mean multiply or it can mean divide. Are we splitting that 3 up, or are we using that 3 again and again? Again and again, which means we're going to multiply 3 blocks per minute times the number of minutes that he's on his skateboard. Well, how many minutes is he on his skateboard? Well, it might be 3. We don't know just yet. For right now, it's M minutes. That's what we're trying to find. Okay? So we're taking the 12 that he's already ridden plus 3 blocks per minute times the M minutes that we're trying to find. Now, what about this 26, this total distance? What's been happening with those totals? Okay, that's what it's equal to. That's the final amount. That's what we want this to become. We want to know when is this going to equal 26. Because the 12 plus 3M, that's how many blocks he's ridden. We want that to be 26. We want to reach that 26 block distance from the school to home. Okay? Okay, so like I said, guys, I'm confident that we can solve these equations. I want to look at building them some more. So let's flip over to the back, and let's take a look at the ones on the back. Okay, so let's look at number 3. Okay, number 3, we're going to read it 3 times, and the first time we read through, the only thing that we care about is defining a variable. So let's read it the first time for us, please.
Homer, Lenny, and Carl found a box full of donuts in the break room at work. They split the donuts evenly. After Homer ate 3 of his donuts, he had 8 left. Write and solve an algebraic equation that we will tell how many donuts were in the box.
Okay, thank you. So, what's our unknown in this story? What are we trying to find here? What are we trying to find? Good. How many donuts in the box? That's our variable. That's our unknown. Donuts in the box. Now, we might think that it was 12 donuts in the box, but we don't know how many were there when Homer, Lenny, and Carl got there. It may have been less. Maybe they condensed a bunch of boxes into one. So who knows? But this is our unknown amount. This is what we need to find. Now, we get to pick whatever variable we want. So, what do you want to use this time? Sure. We're looking for how many donuts in the box. You get to pick whatever variable you want. Well, that's how many he ate. What we're doing right now is picking a letter or picking a variable. Sure. D for donuts in the box. Okay? Now, guys, it's super important that we pick a variable. Okay? We list what it represents, but we also need to choose what letter we're going to use, because I don't want to have to write donuts in the box in my equation. I use D as a variable to represent that, and every time I see the letter D, I know it means donuts that were in that box before Homer, Lenny, and Carl got to them. Okay? Now, we read it a second time, and the second time we read through, that's when we look for the numbers and the operator words. Okay, so let's read it a second time, please.
Homer, Lenny, and Carl found a box full of donuts in the break room at work. They split the donuts evenly. After Homer ate 3 of his donuts, he had 8 left. Write and solve an algebraic equation that will tell how many donuts were in the box.
All right, so now what we need are some numbers and some operator words. So what numbers do we see in here? What numbers do we see? 8, okay? 8, and what was 8?
How much is left?
Good. 8 was how many donuts were left? Okay, that's how many donuts were left at the end of the story. Okay? What else do we see? What are some other numbers?
We see the number 3.
Okay, and what's 3 all about?
That Homer ate 3 of the donuts.
Okay, those are the donuts that Homer ate. Okay, there's one more number in there, and it's kind of a sneaky one. Kind of a sneaky number.
There's number 3 for how many order?
Very good. Okay, 3 is for the people splitting. Okay, they're splitting up the donuts. Homer, Lenny, and Carl, that makes 3 guys splitting up the donuts. Okay, so now let's read it a third time. Let's think about what operations are going to fit in here. Okay, so let's read it a third time.
Homer, Lenny, and Carl found a box full of donuts in the break room at work. They split the donuts evenly. After Homer ate 3 of his donuts, he had 8 left. Write and solve an algebraic equation that will tell how many donuts were in the box.
Okay, so we don't know how many donuts we started with, but we know that that's what we're looking for. We start with D donuts in that box. Okay? Then what happens to that box of donuts? What happens in the story? Samir? Well, something else happens first. They got split between the 3 people. Okay, so splitting. What operation is that? What math operation is splitting? Division. So we're going to take the donuts and divide them by 3. Okay, and that's how much each one of them walked out of that room with. Okay, then what happened? Then what happened? Homer ate 3. Okay, what operation is eating 3 donuts? What operation is going to be eating 3 donuts? Subtraction. Okay, so we've got donuts divided by 3, and we're going to subtract the 3 donuts that Homer ate. Go ahead. Good. Very good, okay? This is how many is left at the end. That's the result. So this is going to equal 8. Okay? So we have D divided by 3 minus 3 equals 8. All right, now, we've been building enough of these. We built 3 equations. Let's solve them. Okay, so let's take D divided by 3 minus 3 equals 8, and let's solve it. Okay, where do I begin? Where do I begin? Who haven't I heard much from yet? Chow? First thing, what's the first thing we're going to do to solve this equation? First thing we always do. Very good. The vertical line through the equal sign. followed by what?
But, make sure that
Good. And what operations are being done to the variable? Good. They're dividing by 3, and then they're subtracting 3. So let's work backwards and do the inverse operations on both sides. And what will we do? We're going to add 3 to both sides. Okay, what's that going to give us? Well, sorry, how about the minus 3 plus 3? What happens there? Good. D divided by 3 minus 0 equals 8 plus 3 is 11. Okay, so now D over 3 minus 0 is just D over 3. Okay? And look at that. They're not subtracting 3 anymore. But they are still dividing by 3. So what are we going to do? We're going to multiply both sides by 3. Okay? And what's that going to give us? Very good. D over 1 equals 33, which means D equals 33. Now, guys, this is a story problem. The question is asked with a complete sentence, so we answer it with a complete sentence. Okay, who can give me a complete sentence here? Very good. The question was, how many donuts were in that box? Well, we solved it. We said D was the donuts in the box, and we said D equals 33. So we would say there were 33 donuts in the box. Now ask ourselves, does that seem reasonable? Is it reasonable to have a box with 33 donuts in it? Yeah. I mean, it's a kind of a lot of donuts in one box, but it could be a multi-level box. So sure, 33 donuts in the box. Okay? All right. Let's go back and talk about Bart and Lisa. All right, let's talk about Lisa saving up for her phone. So we've got 45 plus 55W equals 250. What's going to happen first? Vertical line through the equal sign. Followed by what? Followed by what? The note. And what's the note going to say? Good. Okay? And the multiplication happens first. Okay, order of operations, I know it's from left to right, the addition's first, but order of operations says that multiplying by 55 happens first. Okay? So, what comes next? What comes next? Well, we want to work backwards, though. And the last thing that was included was that 45. So that's the first thing we need to get rid of. We need to subtract 45 from both sides. Okay? And if we subtract 45 from both sides, 45 minus 45 is 0 plus 55W equals 205. Okay? Now what? What's 0 plus 55? W. 55W. So what are we going to do here? Good. We're going to divide both sides by 55. Now, 55 divided by 55 is 1. So I get 1W equals, and then if I do 205 divided by 55, we'll get 3.72 repeating. Okay, and the 7 and the 2 are what's repeating. So W equals 3.72. We put the repeating bar over both the 7 and the 2. Okay, but we had a problem like this yesterday. She's not going to babysit for part of the week. And if she does, she's probably not going to get paid too happily for it. Okay, she's got to work the whole week or not at all. So what has to happen here? Do I round that up to 4 weeks? Or do I leave it at 3? And 3 will be enough. What do you think? Should I round that up to 4? Or should I leave it at 3? Round it up to 4. Okay? If she only works 3 weeks, that's not going to be enough. She's not going to have enough money saved up. Okay, so she needs to work that extra week. So we'll say Lisa has to babysit for 4 weeks. Okay, now ask yourself, does that seem reasonable? Does it seem reasonable that she's going to work for like a month to save up the money to buy something she wants? Does that seem reasonable? Sure, saving up money in a month? Yeah, we can do that. All right. Let's talk about Bart. We've got our equation. 12 plus 3m equals 26. Okay? What's going to happen first here? What's going to happen first? Before anything else, what's the first thing we do? What do we always do first? Vertical line through the equal sign. Okay, followed by a what? What comes after that vertical line? The note. And what's the note going to say? Okay, just keep in mind, order of operations supersedes the order in which we see it. So it's getting multiplied by 3 first, and then they're adding the 12. Okay? Because we're going to work backwards. So if the sorry? Okay, well just keep in mind, order of operations. We can't go away from order of operations. So, we have our note. What's going to happen here? We're going to subtract that 12 from both sides, and what's this going to look like then? Well, give me the whole thing. 12 minus 12 is? Bring down the plus 3m. And then how about 26 minus 12? 14. Okay, and 0 plus 3m? So we have 3m equals 14. And look at that. They're not adding the 12 anymore. Okay, but they are still multiplying by 3. So, what do we do? What do we do? We'll divide both sides by 3. Okay, and what's that going to give us? Well, there's going to be a remainder. Remainder of how many? So we put that 2 over 3. And we could say 4 2/3, or 4.6 repeating. Okay? Now, let's write our complete sentence answer. So M is how many minutes he's on his skateboard. How many minutes is he on his skateboard? Dalton? About 5 minutes, but we can actually be precise on this one because there are fractions of minutes. Okay, we call them seconds. So we can say Bart will be on his skateboard for 4 minutes And how many seconds? How many seconds would 2/3 of a minute be? How many seconds would that be? All right, so how many seconds in the minute, or excuse me, how many seconds that 2/3 of a minute is? First, we need to think how many seconds are in a minute. Well, there's 60 seconds in a minute. So how many seconds would 2/3 of that minute be? Yep, 40 seconds. So Bart's going to be on his skateboard for 4 minutes and 40 seconds. Okay, now ask yourself, does that seem reasonable? Okay, do you think Bart could get home from school in about 5 minutes? Sure, on a skateboard he can get home, he can get 26 blocks in 5 minutes, sure. Okay, so we're good on solving. Okay, I knew we would be. We can all handle the solving these equations. The tough part is when we're building those equations. And guys, it all comes back to this. We need to define the variable. We're going to read this story 3 times. And the first time we read through, the only thing we care about is defining that variable. Very, very clearly. Okay, what it is equal to, what are we looking for? It's always going to be whatever the unknown is. So we want to know how many weeks she has to babysit. That's our variable. How many minutes on the skateboard? That's our variable. Then we read it a second time, and that's when we look at those numbers in operator words. The third time is when we build the equation. Okay, we don't want to run to the equation, guys. We want to take our time. We really want to think it out.